Welcome back. Let's understand the Memento Design Pattern in this course. So we before understanding the concept, let's see one example that we have seen as a developer. Many times we have faced this issue. What happens when database, when you are saving a lot of objects, right? Like it's a transaction. When we start a transaction, there is a multiple points and multiple table that we are getting updated. What happens when between these 10 steps, suppose at the fifth step the transaction get failed due to some reason in database exception is coming, then what will you do? So at that moment the database handle these things, and what it do, it just reward all the changes that he had made previous to step number 5. Like suppose in step 1 it is saving some data in table X, in the step 2 it is saving some data in table Y. So all these are intermediary steps. They are not making the permanent changes. They just they're just saving the state. And once the whole transaction get completed without any error, then this get commit as a transaction. Then this transaction is considered to be complete transaction, right? Apart from that, one more example that we have seen in Amazon AWS services, we are having the database services, right? So Amazon provide one service to take the snapshot of your database. What is this? Snapshot is a backup of your database, right? What it does do, on a periodic on a periodic base, it take the snapshot of your database. It take just a state of the database at that particular moment and saved it. So whenever suppose in future your system get crashed, or somehow your database get corrupted, so at least from that snapshot point you can get back to your database and you can start work. Right, so this is the benefit of keeping the snapshot of any type of database or something. In the same thing we are going to implement in the OOPS concept. So how this is called Memento Design Pattern. So sometimes it is very necessary to record the internal state of an object, and this is required when implementing the checkpoints and undo mechanism. So in this the whole process, one thing we must ensure that the encapsulation should not be break. It should not be violated. So memento is an object that store the snapshot of the internal state of another object. Like that another object is nothing but it's a memento originator. So the undo, what the undo mechanism will do? This undo mechanism will request the memento from the originator when it needs to the checkpoints of the original state. So what happens? It kept on you can keep the saving the state at some particular level. You can give this level something name like level 1, level 2, and suppose when you were at level 5 and you want to now go back, or you want to some undo operation, so what will you do? You just ask your current current executor, go back and restore the level number 4. So it will remove all the things after whatever happened after level 4, and it will keep the state till level 4 only. So this is how it's work. So this will become very useful when we are implementing the checkpoints and undo mechanism that lets user get back to get out of the tentative operations or recover from the errors. So entrust other object with the information it need to revert to a previous state without exposing its internal structure and representation, right? So there are three actors in the memento patterns. One is the memento contain the state, the object to be restored, that is memento. I mean the object itself which state has to be restored. One is the originator class, or is the responsible guy which creates and store the state in a memento object. Its work is to create the memento or create the snapshot and save the object. And caretaker object is responsible for restore the object state from memento. So if memento it is saying like go restore to up to the level 4, level 3, so it's a caretaker work, it's a responsibility of the caretaker object. So we'll see while implementing how this thing get implemented, and how this become very useful in daily to daily programming things, and this make your program very robust. At any point of time you always have a backup, or you can say always have a previous state that can be used. We'll see all this operation in the next session where we'll implement it. So until then, bye.